Okay, I believe everything is set. Hello, dear colleagues. Uh, Welcome to our science talks of Ukrainian Scientific and Educational IT Society. Today I'm thrilled to be joined by Nestor Maslej, Research Manager at Stanford University Institute for Human-Centered AI. Nestor leads the AI Index and the Global AI Vibrancy tool, and actually he is an editor-in-chief of the AI Index report. Yeah, and I don't want to steal your time anymore. So Nestor, uh, the stage is yours.
Thank you. Well, it's super exciting to be at this group and to kind of speak to you guys about some of the latest trends that I'm seeing in AI from the lens of Stanford and the AI Index. And I want to start a little bit by talking about what the index is. So the index is an initiative. It's currently in its eighth year, and it's a report that aims to track, distill, and visualize information on key trends in artificial intelligence. And it's a report that was created in 2017 by a diverse committee of AI thought leaders, people like Jack Clark, who's one of the co-founders of Anthropic, arguably one of OpenAI's biggest rivals, Eric Brynjolfsson, who I would say is one of the world's leading digital economists, and then James Manica, who now is really heading all of Google's AI research activities. And these individuals came together in 2017 because they understood as far back as then that AI was going to be a transformative technology, and that as such, it was going to be necessary to have a report that really could kind of tangibly speak to what is actually going on in the space. And that's really what the index is trying to do. We're trying to tell a story of how much better the technology has gotten, what are some of the new economic trends that we're seeing, what are some of the trends that we're seeing as it relates to ethics, policy. We really try to kind of be a one-stop shop or repository for information on trends in the space of AI and kind of understanding where the space is going and how it is going to be evolving. Now, we also collaborate with a lot of researchers at Stanford, worth kind of shouting them out that it's not just an individual effort, it's something that we work with a lot of different people to do. We also work with a lot of data vendors across the world that give us data for the report. Of course, we collect information on some of this data ourselves. And we've been privileged over the years to have been featured in newspapers across the globe and have been cited by governments and government agencies across the globe, as well as, businesses and by cited by different business leaders across the globe. So with that, let's kind of dive into some of the top takeaways. Now, the first thing that I'm kind of seeing is that AI performance is really continuing to improve. And I like to kind of start these presentations with kind of images because I think it really puts into perspective just how much better the tech has gotten. One of the things that we asked Midjourney, one of the world's best text-to-image generators, to do is to give us a hyper-realistic image of Harry Potter over time. And we asked Midjourney this prompt from the first version of Midjourney that came out in February of 2022, all the way to the most recent version that came out in July of 2024. And if you juxtapose, for example, within a short span of 2 years, just how much better the tech has gotten, you'll notice it's a pretty substantive and massive improvement. And it really puts into perspective just how much the technology has gotten better. You can also now go to websites like whichfaceisreal.com, which will generate a artificial face and then give you an image of a real one, and then you can kind of decide which one you feel is more relevant and salient. And the one that is in fact real here is the one that's kind of highlighted on the left. And it's not just the story of images. One of the exercises we did at the index this year is looked at progress in video generation. And if you, for example, asked one of the top video generators to give you an image of Will Smith eating pasta, this became a bit of an internet meme. You see that in December of 2023, you're not really kind of getting very active, very kind of engaged, and very high level images in this particular moment. Now, if you fast forward to October of 2024, again for the prompt Will Smith eating pasta, you see that it improves in some ways, but there's still still some kind of significant limitations. The fingers look a little bit funny. The pasta seems to be levitating into this guy's mouth. Not the most kind of accurate and faithful representation. But then when you kind of go to February of 2025, it's much better, no more levitation. There's still some kind of awkwardness. The fork seems to be inconsistent in its sizing. But again, in comparison to what you had a year or so ago, it's a fairly substantive and massive improvement in the underlying technology. Now, those are kind of some of the examples that really highlight how the technology has become better. It kind of really points to you very clearly just how much it's improved, but it's also very interesting to kind of see what kind of technological paradigms we're kind of witnessing that have led to some of this technological improvement. So one of the big ones is that in the last year, we've had a lot of these new reasoning paradigms like test time compute that have really been able to kind of significantly improve model performance. So if, for example, you kind of juxtapose the performance of GPT-4o versus o1 and o1 preview, GPT-4o, of course, being the base model, and o1 preview and o1 being these models that use test time compute. Test time compute is, of course, this ability to kind of reason iteratively, that you prompt these models and then they have the ability as you prompt them to kind of reason about their responses. You'll see that it is the o1 versions and the o1 preview versions that outperform GPT-4o on virtually every benchmark, especially some of these mathematical benchmarks like Math and AMY 2024, which are designed to be kind of quite challenging and quite difficult. And if you talk about AI in the last year, you of course need to mention the tremendous impact that it's had in the space of science. If you juxtapose, for example, the performance of AlphaFold 3, this kind of model that was created to predict protein structures, with a lot of other leading models, you'll find that AlphaFold 3 tends to be one of the best models in the space and the most high performing ones. And of course, AlphaFold 3 led to the Nobel Prize in Chemistry being awarded to people at DeepMind that were kind of very instrumental in its work. And we not only kind of saw that DeepMind was rewarded with kind of high level research here, it was also people like Jeff Hinton who won a Nobel Prize in physics. And that kind of really illustrates some of the tremendous ways in which AI has been able to kind of impact science. Now, one of the big buzzwords that we've seen kind of in AI in the last year has been kind of all this talk regarding agents. And there is kind of research that is suggestive that AI agents are showing some degree of early promise. So if you look at some of these benchmarks like Rebench, that look at how well AI agents are able to do computer science tasks, the takeaway seems to be that in lower time budget settings, so when you kind of have strict limits about how much time you are given to do any AI task, then the AI systems outperform the score of humans. But the more time you give to humans, the better humans are able to execute. And this kind of, I think, still illustrates an important limitation in the function of AI systems, that a lot of these AI systems are still really being asked to kind of do quite narrow and quite specific tasks. And that's something that, of course, humans have the ability to think much more iteratively and flexibly. Now, when I typically do this presentation, I like to kind of end this technological section by looking broadly at benchmarks. Where are we? And this is a slide from the 2024 AI Index. And back when we did that particular report, we kind of noted that AI is exceeding humans on some, but not all benchmarks. So if you look at these kind of intellectual tests for how well AI systems are able to operate, you'll kind of notice that on a lot of these benchmarks, AI systems are already doing better than humans. But there's maybe kind of a few where they're lagging behind some of the benchmarks on the far right. But if you fast forward to this year, you kind of find that there's really not a lot of benchmarks that are left here, right? You'll notice this benchmark for competition level mathematics that's kind of in the teal on the screen. We've kind of gone from AI systems that scored roughly 10% relative to the human baseline for that benchmark to systems that all of a sudden are scoring in excess of 100%. And for reference, the performance on that particular benchmark, the baseline, is the performance of a three-time International Math Olympiad gold medalist. So it's not like I'm sitting at home and I'm doing the problems and they're testing them against me. It's basically people that really understand the space and people that really are kind of fluent in mathematics. And 2023 was a year in which we saw many new benchmarks that were released, like GPQA, MMMU, and SWE-bench. These benchmarks were kind of explicitly created for the purposes of challenging the best AI systems. They were designed to be very hard and very difficult. And on virtually all of these benchmarks, we've seen massive progress in the last year. Again, evidence of the fact that AI as a technology seems to be getting better and better, and that the improvements don't really seem to be slowing down. And I think for me, this kind of means that even if the developments were to stop today, which is unlikely, we already have in our hands a technology that's incredibly powerful and incredibly potent. And in a lot of ways, the kind of challenge with the technology is less about how much better can we get it to be, but more about figuring out how can we get businesses and people to use the technology even better. Now, we're kind of at a moment with these benchmarks where some of the new benchmarks that are being proposed, like humanities last exam, are literally being labeled as the last ever academic benchmarks that we're going to need to ask these systems. That's how much better it's getting. But again, progress is really moving forward rapidly. We published the AI index last month, and if you look at the score on these benchmarks in the last month, you'll notice that basically since then we've already had a model O3 that has kind of doubled the top score that we posted the last time that we kind of did this analysis. So really kind of illustrative of just how much progress is improving in this space. But I think there's kind of an interesting kind of final remark to be made here about where do we actually go with benchmarks? Benchmarks, of course, are one of the flagship ways in which we try to monitor progress in the AI ecosystem. But there's new research that's come out of Stanford that suggests that benchmarks can suffer contamination issues, unreliability issues. They can suffer from problems where they're not really kind of trying to model well the phenomenon they're trying to observe. And I think as a research community, we really want to kind of think to ourselves, okay, where can we go in the future as a means of continuing to kind of evaluate and track the progress of a lot of these systems? So that's the kind of first highlight, which is just that the technology is really getting better. And I hope I've kind of shown you some data that points to just how much better it's gotten, and more specifically, how it's become kind of increasingly improving and some of the ways in which the improvement has been realized. Now, as the technology has gotten better, I can also really say that AI is increasingly embedded in everyday life. I think you see this in a lot of different ways. There's more FDA-approved AI-related medical devices than ever before. We go, for example, from 6 such devices in 2015 to 110 or so in 2020 to over 200 in 2023. Self-driving is also on the rise across the world. Now, in the United States, if you go to certain cities like San Francisco, Phoenix, LA, Austin, you'll notice there's Waymos driving around everywhere. There's also research that suggests that Waymo drivers tend to be a lot safer than human drivers on a variety of benchmarks for airbag deployment, injury reports, police reports. And this isn't just a phenomenon that is limited to the US, it's also an international phenomenon. Places like China have also seen really massive uptakes of self-driving. Companies like Baidu have been really forward-thinking in kind of propositioning a lot of the driving that we see in this particular space. So the tech is getting better. It's becoming more embedded in all of our lives. I think to me, one of the more exciting trends that we're seeing recently is that business really seems to be all in on AI. And this is important to know, right? Because anytime we see a new technology develop, I think there's a lot of open questions that are asked about, is this just going to be a hyped technology that might not kind of deliver some of the values or promises, perhaps like cryptocurrency, or is this going to be something that is going to deliver for businesses and is going to be very useful? And I think the data does seem to suggest that businesses are really thinking quite tangibly and actively about the technology. So first and foremost, one of the things that we find is that business usage of AI is really increasing. So if you look at how many businesses report using AI in at least one function, we basically have increases from roughly 20% in 2017 to, let's say, 55% in 2019. And it kind of plateaus then for 4 or 5 years, and then there's a fairly significant jump all the way to 78% in 2024. You can almost call this the Chat GPT effect, where people see that AI is here and are really trying to use it a lot more in their operations. And in the background to all of this, we've seen massive increases in generative AI investment. We go from roughly 5 billion in such investment in 2022 all the way to exceeding 30 billion in 2024. And the particular kind of geographic areas that lead in this investment in the world are unsurprisingly the US. It's kind of far and away the place to be when it comes to AI related investment. And as China's kind of investment share has declined recently, there have, there have been certain places like Europe that have come in to really fill this burden and find a way to kind of take over some of the things that are going on. And I think now some of the reasons why businesses across the world are really, quite openly thinking about these AI trends is because there's now a lot of really good research which shows that AI has very positive productivity impacts. So you can look at research that comes from Eric Brynjolfsson that shows that people that use AI in customer support settings, they answer more hourly chats than those that do not use AI. There's research that's come out of MIT that shows that AI has had massive impacts on science. If you look at, for example, scientists that use AI versus those that do not, scientists using AI discover more materials, they file more patents, and this isn't something we just kind of highlighted now. This is something that we profiled in last year's AI index as well. Computer scientists that are using AI across a variety of different tasks tend to get their tasks done in a lot less time than those that are not using AI. And this isn't just something limited to computer science or perhaps science. You also see these impacts in consulting and law. Consultants that use AI are more productive, they do work of substantially higher quality. And lawyers that are using things like GPT-4 can draft contracts more quickly, can draft complaints more quickly, and in some cases can even do this work at substantially higher levels of quality. So I think one of the things that you see is that there's really evidence that AI at the minimum is going to improve the quality of time that you need to kind of use to put in to do the work. And at the maximum, it's going to lead to work of substantially higher quality. Now, another kind of big trend that we see when we look at this kind of literature that is trying to understand the positivity impacts is that it seems that AI has differential impacts across skill groups. So if you look at the impact that AI has on low versus high skilled workers, you'll notice that in most of these studies, it is the low skilled workers that gain a lot more from a productivity perspective than the high skilled workers. Now, at the end of the day, it is still the high skilled workers who are given AI that are performing at much higher levels than those that were not given AI, but the lower skilled workers seem to benefit the most. Now, this isn't always the case. I think there are certain examples where it has been the case that it is actually the high skilled workers that tend to benefit the most. So more specifically, I'm thinking about the study that we saw on AI and science. In this particular study, it was documented, for example, that it was actually the best scientists that were able to leverage AI the most. So perhaps the suggestion from the literature as a whole is that the impact that AI has on science and scientific discovery and more broadly productivity is quite kind of task specific, that depending on the task and the skill that you're talking about, AI might have different impacts on low versus high skilled workers. But this, of course, leads to a lot of interesting questions about what the future holds for the labor force. I mean, if you look at surveys done on business managers that are kind of asking them what impact they expect AI to have on organizations' workforces, you'll notice that most of them still report that AI is going to lead to a decrease in the amount of jobs. But the amount that are reporting a decrease in 2024 is less than those reporting a decrease in 2023. So perhaps people are using this technology and kind of realizing that, hey, it might not necessarily have a lot of the negative productivity impacts that a lot of people anticipate and think about. So again, the trend that I've kind of tried to demonstrate in this presentation is that the tech is getting better. It's becoming more embedded in all of our lives. Businesses are starting to step up as well. And we also see very crucially that governments across the world are also kind of waking up to the presence of this technology. So if you look at, for example, the number of AI-related regulations in the United States, you go from one such regulation in 2016 all the way to 60 in 2024. And these regulations are coming from an increasingly diverse amount of AI-related regulatory agencies. So it's not just the case, for example, that the Centers for Medicare and Medicaid are thinking about it. You also have, for example, the Executive Office of the President that's getting in on the party, the Health and Human Services Department, the Office of the Secretary. So people across the globe are really kind of actively thinking about AI and some of the ways in which it might have kind of impacts. Now, this is a phenomenon that, at least in the US, you see on a lot of different levels of government. There are more AI-related bills passed on the state level year over year, and the states have been especially active. You see certain states like California, Utah, Maryland, Virginia that have passed the most. The states have been especially active regulating AI-generated deepfakes. This is one area where we see a lot of state-level regulation. There's also been a lot of work regulating deepfakes in intimate imagery. And of course, this is evidence of how AI is having some pernicious effects society-wise, and we can kind of see how states have taken some steps to deal with this. I've talked about some American examples, more agencies passing it, more states passing it, but the kind of story of more legislation is not just an American one. The number of AI-related bills passed into law across, 120 different geographic areas has really gone through the roof in the last little while. You kind of go from one such bill being passed in 2016 all the way to 40 in 2024. But I think to me, one of the biggest kind of narratives here is that governments have really kind of stepped up on AI-related investment. So in 2024, you saw several governments across the world, Singapore, Abu Dhabi, India, Canada, China, that have taken kind of very concrete steps to kind of say, okay, we are going to invest substantially large amounts of money to broaden what we can do from an AI perspective. So this is evidence to me that governments are seeing AI as a technology that can really have a lot of value from a business perspective and trying to kind of commit more money, commit more funds to it. Now, the public is also reacting to AI. AI isn't just kind of a story that's happening in business boardrooms or perhaps policymaking parliaments. It's also a story that's kind of taking places across the kitchen tables in the world. So if you look at, for example, global AI optimism, it's rising, but there are still very sharp regional divides that remain. This chart is looking at how many people across different countries in the world agree with the statement that products and services using AI have more benefits than drawbacks. You'll notice that for virtually every single country in this sample, there are more respondents that kind of agree that AI has more benefits than drawbacks now than agreed in 2022. And some of the sharpest rises that we've seen have been in countries like France, Germany, in countries like the United States, Canada, that previously were kind of quite negative about the technology. Now, it's again important to kind of note here that we still have fairly substantial regional divides that kind of remain regarding AI usage. And these divides are kind of largely concerning the fact that there are certain countries like China, like Indonesia, like Thailand, that are much more optimistic about AI than some of these other countries. And I think there's an interesting question to ask here. Why is it the case that this kind of optimism is so varied? Why does the difference exist? And what impact might this have on the kind of future course of AI development? It's also interesting to see how people are reacting to some of the new AI technologies that they see in their daily lives, that they see, for example, on the streets. If you look at the attitude of Americans towards self-driving vehicles, you'll notice that most Americans are still deeply afraid of self-driving cars, despite, again, a lot of this evidence that I showcased to you guys earlier, which is really trying to say that self-driving cars in a lot of ways are a lot safer than non-self-driving cars. If you also look at public opinion more broadly, there is, very clearly now broad support for AI regulation among local US policymakers. Most US policymakers now agree very strongly that the US government should support AI regulation. Now, again, the devil is really in the details here because although most officials, including most Republicans and Democrats, agree that there should be more regulation, the question of what regulation is actually appropriate, whether you use, for example, regulation for UBI or regulation for reskilling workers, that tends to vary. That tends to be kind of quite different. And, you can kind of really see here how there's a diversity of perspectives and a diversity of opinions on how this field should evolve. So the first kind of highlights that I've ran through for you guys, the kind of highlights that relate to the tech getting better, different people reacting, I think those are highlights where we have a bit more of a clear narrative. I think the next few things that I'm going to suggest are kind of evidence of, trends that are changing or trends where there are kind of different, perhaps, narrative storylines evolving. And one of those where you see very clearly is that of geopolitics. The geopolitical race that's surrounding AI is evolving. So if you look at, for example, who is leading in the production of top AI models, it's still the United States by a very far margin. The number of notable AI models produced by selected geographic areas is really leading with the United States. The United States produces more notable AI models than any other country in the world. And it's been a similar story for the last 20 years where more of these models have come from the US and China than virtually any other country. And the US is also leading in highly influential research. We did a very interesting analysis at the index this year where we looked at the number of highly cited publications in the top 100 by select geographic areas. So this is kind of really looking at which countries are leading when it comes to producing AI-related research. And in all three of the years that we analyzed, 2021, 2022, 2023, there seems to be more research that is kind of coming out of the United States than virtually any other country in the world. Now, the big story that we saw in the last year is that China is starting to really close this performance gap. So if you look at, for example, the delta between the top performing US versus Chinese models, it has shrunk from roughly 100 points in January of 2024 on LMSIS, this popular benchmark for assessing AI systems. It has shrunk from roughly 100 to less than 30 in the span of a year. So the best Chinese models are getting increasingly more high performing. China also kind of leads in certain dimensions like AI research publication totals. There is more AI related research that is kind of coming out than ever before. And China is really kind of leading in this domain. China also leads in the total number of AI patents. And in certain areas like industrial robotics is also really well positioned. So this is an area where we're kind of seeing a lot of evolving discourse. And I think the point that we're trying to kind of make here is that the technology is growing, it's changing, and it's leading to kind of different interpretations of who's going to be leading when it comes to this kind of very crucial geopolitical question. Now, another big topic that people, bring up and kind of think of when they mentioned AI is responsible AI. And we have research now that is really kind of suggestive to us that the responsible AI ecosystem is evolving in a rather uneven way. How do we see this kind of evolution? Well, first and foremost, there's more AI-related incidents than ever before. If you look at the number of reported AI incidents, these are again organizations that are tracking how many such incidents exist. There are more and more incidents now than ever before. And as we kind of see more of these incidents increasing, we see kind of a increasing, let's say, increasingly fragmented landscape as regards to responsible AI. So with the question of standardized benchmarks, for certain kind of general capabilities, so these are capabilities that are looking at general things that models can do, like how well can they answer general language questions like MMLU? How well can they answer general scientific questions like GPQA? There is consensus across the board. Each model developer is really kind of thinking deeply about these things and deeply about these points. They're all testing on the same particular models. But when you flip the script and you look at the world of responsible AI, so this is kind of looking at benchmarks for things like how biased are models? Are models actually telling you the truth? How vulnerable are models to adversarial attacks? You'll notice that there is no consensus. Certain developers are testing on some benchmarks, other developers are testing on others. In certain cases, there are certain models that aren't being tested on any of these notable RAI benchmarks. And I think what this really tells me is that there isn't a standardized level playing field when it comes to RAI. Now, this isn't suggestive of the fact that these companies aren't prioritizing the topic. I mean, all of these companies, Anthropic, OpenAI, they all have teams that are really dedicated towards doing a lot of this responsible AI research work, but the teams are fragmented and the teams are kind of doing their own thing and they're testing on different types of problems. And this is problematic because, if you're a business that is kind of thinking about using the technology, you need to be very kind of intentional and mindful in trying to kind of really fully and properly understand which model you want to use and what some of the trade-offs are in using one model versus the other. But this research is really kind of concretely showing that there is no kind of clear trade-off, that there is no kind of ability to look in a standardized way on these particular benchmark points. Now, in the absence of this kind of responsible AI standardization, academics have really stepped up with various benchmarks like Helm Safety and AirBench, benchmarks that are kind of designed to offer this standardized suite of model evaluations. On the business side, we also find that a lot of businesses are still very early on in their RAI journeys. So if, for example, you're asking businesses, do you consider certain AI risks as kind of being relevant? A lot of these organizations will say that they consider a lot of risks as being relevant, but actually they're taking a lot less steps mitigating different types of risks. And over time, it seems that while certain risks like privacy and data-related risks are increasing, other risks like reliability risks are also increasing. It seems that the biggest increase year over year is financial risks. So for this particular survey, we partnered with Accenture, and this is kind of looking at how the different kind of RAI-related risks reported by organizations are changing over time. And you'll notice that the financial risks really seems to be kind of going through the roof. There is much more risks on that front that are reported, which is kind of highlighting how a lot of these companies are really kind of thinking about, first and foremost, is AI as a technology actually kind of delivering ROI across the business value proposition. Now, on responsible AI, in absence to all of this, policymakers have really risen to the occasion. So the last year was a year in which there was a lot of notable RAI policymaking milestones that were passed in the last year. In places across the world, organizations like the OECD stepped up. Organizations like the Council of Europe adopted the Council of Europe Framework Convention on AI and Human Rights, Democracy, and the Rule of Law. The G7 authored a digital competition communique. All of these organizations are thinking much more kind of actively and tangibly about some of the ways in which AI technologies are potentially affecting some of the things that they're ultimately doing. All right. So with that said, with kind of the responsible AI bullet covered, let's now get to another kind of highlight that perhaps seems a little bit paradoxical, but AI as a technology is becoming a lot more accessible, very important, yet industry is continuing to lead its development. Now, one of the ways in which AI is becoming more accessible is through falling inference prices. So this chart is looking at how much it costs to use or query AI models across different benchmarks, different levels of intelligence. I think for your sake, the most important line in this chart is going to be the one on the far left for GPT 3.5. GPT 3.5, for those unfamiliar, was one of the models that served as the original baseline to ChatGPT when it was first released. Now, the cost of using a GPT 3.5 level model has decreased from roughly $20 per million tokens in November of 2022, all the way to 7 cents per million tokens in September of 2024. And you've seen these kinds of decreases in cost largely because models are becoming more efficient. You can get better performance from smaller models, as you see in this chart. This chart is looking at how big, in terms of the number of parameters a model has, what is the smallest AI model that scores above a 60% on MMLU, this popular benchmark for assessing the performance of various models in the AI ecosystem. You'll notice we go from kind of models that are roughly $500 billion, 500 billion parameters in size to models that are roughly 4 billion in size in May of 2024. So the size of the models that kind of score above a 60% has really kind of declined over time. And this decline in a lot of ways has been driven by things like better performance of hardware. So if you look at the kind of price performance of leading NVIDIA data center GPUs, then you find that some of the more recent GPUs that have been released, like the H100, substantially outperform other GPUs that have been released, like the A100, which was from 2020, and the V100 from 2016. The gap between also the best top closed and open models has also decreased. It used to be the case that last year, there was a very big gap between the best closed and open systems. And you could really kind of say at that point that there might be a very kind of realistic trade-off to deciding to kind of build with a closed model versus building with an open one. I wouldn't really kind of say that this trade-off exists anymore, that the gap between the two has really kind of changed. Still, industry is really kind of continuing to race ahead in AI. If you look at the number of notable AI models by sector, most of these models are coming out of industry and very few are coming from academia. And since 2014, the top organizations in terms of producing these models have been organizations like Google, Meta, Microsoft, a lot of universities like Carnegie Mellon, like Stanford, like UC Berkeley are really lagging behind. And part of the reason that industry is really in a position to be leading a lot of these AI developments is just that it really costs a lot of money to train these systems on the frontier. I talked earlier about how inference prices are falling, how models are becoming less expensive to use, how smaller models are increasing. That's all very true, but it's the case really in a lot of ways that still on the frontier, it costs a lot of money to use the models. If you look at, for example, the estimated training cost of select AI models in the last little while, you'll notice that you get models that cost, $1,000 in 2017 to models that are costing anywhere from 1 million to 12 million in 2022 to models that in 2024 are costing anywhere from 40 to 170 million dollars. So the kind of usage cost of a lot of these models is really going through the roof, and the training is really kind of becoming a lot more expensive. And this is again all tied to kind of rising computational demands. Researchers are kind of well aware that the more data they pump into the system, the better it performs. And researchers have continued to do this. And as they've continued to do this, the performance of a lot of these models has gone through the roof, but as has their cost. Still on the kind of frontier, inference costs remain relatively high. If you want to use some of the best performing models, then you'll see that these models like O1 and Claude 3.5 Sonnet cost a lot more money to use than some of the perhaps more nimble but less high performing models. And we're now kind of at a moment in the AI landscape where the frontier is becoming more competitive than ever. I think you could say 5 years ago that there was maybe one or two major developers that had access to this LLM technology. Now there's seven, and they all have this technology that is really strong and really capable, and that has a lot of implications for how the space might develop. Now, academics are not kind of completely left out to lunch. So if you kind of look at, for example, the number of highly cited publications in the top 100 by sector, most of these publications come from the academy, and not as many are coming from industry. Now, a few more kind of highlights to wrap up. We did a lot of analysis this year on trends in AI in education, and we find that although AI education is expanding, there's a lot of gaps that remain. So, for example, if you look at the availability of computer science education by country, there are certain countries in the world where, CS is kind of mandated in primary and secondary schools, certain countries in the world where it's kind of only offered in some, and then other countries where it's not mandated at all. And this is kind of all in the backdrop of there being a lot more computer science post-secondary education across the world in different verticals, and information that suggests that teachers aren't really kind of equipped to teach AI. So if you look at the percentage of teachers who feel equipped to teach AI by grade level, this is really not as high as we would want it to be. Last but not least, there's still kind of very important reasoning challenges that remain with these systems. I think that in this presentation, it's easy to kind of talk about all the hype that exists around AI, all the kind of exciting things that are happening, but a lot of these systems on planning tasks still kind of really struggle. They can't kind of execute them really well. And you see this on certain benchmarks like Plan Bench. So this is kind of illustrative of the fact that although the systems have improved a lot, they still struggle with certain issues like hallucination. And that's kind of important to keep in mind as we try to kind of, let's say, fairly assess what these systems can and cannot do. So that kind of concludes my presentation. I hope you guys all learned a thing or two about trends in AI. I hope you guys, check out the report itself. I might actually kind of link the report in the chat just so that you guys can kind of look at it in your own time. I think it's a really good resource for trying to understand what may have potentially happened in the trends of AI in the last year. And now I've kind of intentionally left some time open for questions if you guys want to ask any of those. Thank you very much.
Great, thanks a lot, Nestor. Dear colleagues, we are open for questions. Just raise your hand and you can ask. And we have some questions already in the chat. So the first question, in your opinion, what has a greater impact on AI productivity, hardware development, mathematics, algorithms, or technologies?
So I think it's a combination of all of those factors. I think probably the biggest thing to me is improvements in hardware and improvements in kind of the algorithms. So I think that a lot of that is kind of about mathematics fundamentally, right? So like one of the big, I think, discoveries that was made in the last few years that came out of Stanford was this kind of flash inference, a way to basically make it substantially cheaper to do inference on transformer models. And the PhD that discovered this, I believe he had discovered this purely through kind of experimentations in mathematics. He had found kind of a mathematical approximation that led to this inference being done a lot cheaper. So I think the biggest thing is that, yeah, the hardware has gotten a lot better, which means that it costs a lot less to build these systems. And there's increasing kind of gains that are kind of made in the efficiencies of the models and how they're actually being trained. So that's kind of what I would say is kind of really occurring. And I think the DeepSeek model is a good example of that, where, I think the story there is just kind of finding more efficient ways to build and train these systems.
Great, thank you. Another question. Let's make a forecast for when AI will solve the Millennium Prize problems. For example, Navier-Stokes existence and smoothness, and so on.
So I don't know enough about mathematics or science to kind of give you a good answer to that. I mean, I also think that it's hard to make those predictions, I think for a couple of reasons. I think that generally humans, and I mean, I don't like making predictions because I think I kind of come from the place where I realize that we're not super good at anticipating how these systems may develop and what impacts they might have over time. And I think a good example of this is that if you read a lot of like literature on technological transformation, for example, that was written 10 years ago that looked at like what impact AI systems might have on technologies as they transform. A lot of this literature predicted that AI would come first for a lot of these kind of routine manual jobs. And if you look at like what has happened with AI, AI can't, flip a burger for you at McDonald's or build you a home, but it could arguably do the work of a lot of coders or lawyers. So it could do more cognitive tasks. We didn't anticipate that. So I think it's hard to know exactly when AI systems are going to solve these things, but it's also worth kind of reconceptualizing what we mean by intelligence. I like kind of using this kind of thought experiment where you imagine that if I approached you and said that one of my uncles is a construction worker, one of my uncles is a lawyer, which one is more intelligent? Everybody, most people would probably imagine that it's the lawyer that's more intelligent. We associate law as being this very kind of academic discipline. Now, we have AI systems that can do the work of lawyers. We don't have AI systems that can build buildings. There is still very much an intelligence that is involved in building a building. It involves kinetic movement, kind of coordination. Those are all things that AI systems don't really do as well as humans. So we've kind of improved in certain intellectual tasks, but we haven't necessarily seen improvement in others. And I think it's important to kind of ask how we kind of cognitively define some of these different tasks.
Great, thank you, dear colleagues. Any other questions? So while we are waiting, I have one from myself also. So in Ukraine, we have a lot of actually governance of AI, including national innovation strategy and self-regulation on AI of different companies. And yeah, obviously state of the art in AI in defense tech and military tech. The question is, how can emerging democracies like Ukraine be better represented in global AI data sets?
That's a good question. I think it kind of starts with pioneering a lot of good research at home. So I think, again, a lot of these models, they do share Western opinions. They reflect Western biases. I think a lot of that is just reflective of the fact that they're trained mostly on Western data. And if you want to change that problem, I think it kind of starts with like at a place like Ukraine, having better collection for data there, having more access to kind of open data so people could build with this data, maybe pushing for some kind of sovereign Ukrainian foundation model. I think that would have perhaps been a more ridiculous proposal a year or two ago when the costs were so high. Now, a kind of Ukrainian AI foundation model might not necessarily be as good as the best ones coming from Silicon Valley, but you can still get fairly good ones. And if you kind of commit to building an open system that is kind of free and fairly usable, then that could lead to a lot of kind of positive developments that we then kind of see subsequently. So I think that's kind of all very interesting things that could potentially happen and be kind of introduced as AI is kind of growing and developing.
Great, thank you. And we're actually working on sovereign AI model in
Very
Ukraine.
exciting.
So the next question is how to measure effects on AI of AI on workforce demand in a way to separate from other factors.
Yeah, I think it's tricky. I mean, I think the problem is we just don't have a lot of good systematic data on this particular point. So, what I mean by this is even a lot of the studies that I've kind of highlighted or pointed out to you that look at what impact AI has had on productivity, they come from academy. They're very kind of narrow studies where a couple of people have been disaggregated and separated to do one thing versus another. but it would really be nice to kind of have a systematic multi-year study across industry that looked at how AI has productivity impacts, how is it changing, how much is it getting better. Those are all very important things. So I think in an ideal world, you would kind of build this study and kind of coordinate this initiative, but that of course is something that's a lot easier said than done.
Thank you. We have another question. Do you have any reflections on Gen AI regulations in universities and schools?
Yeah, I mean, I think that schools need to adopt and they need to change. I think that AI technologies can do a lot of wonderful things. I think they can change the way in which learning is done and make learning a much more kind of democratic, open, fair process for a lot of students. But at the same time, I think that AI needs to be one of those things that there might need to be kind of different modes and modalities of kind of educational learning that are kind of encouraged and incentivized. So I think that's one of the things that I would kind of like to see and like to kind of understand in the near future.
Great, thank you. So I have another question. So you have showed smaller models now matching or outperforming massive LLMs. So what does this mean for countries with limited compute infrastructure? Does it democratize access, or does the frontier remain closed?
I think it definitely democratizes access. I mean, I think the frontier still requires massive access to computing, but you would probably say that like the gap in performance is kind of narrowing and really kind of dwindling, and as in the performance gap between the best and the worst kind of AI systems. So I think definitely you do see a trend in democratization, right? Because if this trend kind of continues, you can imagine that in a year or so, we're going to have the best models now. They're going to be kind of incredibly cheap to use and inexpensive. So, I think that's a trend that's kind of worth keeping an eye on, worth kind of seeing in terms of how the field evolves and develops.
Great, thank you. Dear colleagues, any other questions? So if you could advise a country like Ukraine on one strategic priority on AI development over the next, let's say, 3 years, what would it be and why?
Um, it would be to I think that's an interesting question. I mean, I think kind of um, overall, I would say, I think developing sovereign resources, kind of each country is going to be thinking about AI in different ways and different perspectives. And I think it's just kind of important to think, yeah, like how different countries are doing things and what are the priorities that Ukraine has. And then when you think about sovereign computation, that's always a good way to kind of advance those priorities in kind of unique ways.
Thank you. And we have another question in a chat. Will AI be able to influence wars in the coming years?
I think so, definitely. I mean, I think you see a lot of it used in different ways for that already. And there's examples of it, but I think you kind of need to ask yourself, on a high level, how much that is kind of happening and what some of the impacts are going to be here.
Okay, thank you. Dear colleagues, do we have any other questions? We have a time for one last. If no, then thanks a lot for your time. It was amazing lecture and amazing content, very interesting and I believe very useful for Ukraine. So we had Nestor Maslej today from Stanford University. Thanks a
Yeah,
lot,
thank
Nestor.
you very much, guys. A pleasure speaking. Take care.
Thank you.
Nestor,
Bye.
can I ask you the question? Because
Yeah,
I
I could
have
do
the
one
question
more, yeah.
too. I have the question about the models, because, for example, now you said about many models which already proposed by different organizations. And for example, we have now a war, and also we have a very large number of systems which will use AI. how we can use these models, standard models, so they can be used for different things. Maybe it is not reality to use these models. Maybe we need to develop own models. Because,
Yeah, I
for
mean, I think
example, in the war, yes, we have some risks, and there are many standards and many European Commission and NIST recommendation that we have to do something with AI risks. And these risks from models, from these universal models, which we can use. So maybe the reason to develop own models of these risks, and maybe you something propose to us how to do in this situation.
Yeah, I mean, I
Thank you.
think developing your own models just gives you a little bit more control about what you prioritize. And it makes it kind of easier to kind of incentivize a good research community in your country. You know, if you kind of develop some of these models and you make them openly accessible, you can kind of control how the models might develop and grow, and that's very exciting. So I think that's kind of the argument to do it, is just kind of you then can more strategically advance some of your own priorities.
Great. Thanks a lot. So again, it was Nestor Maslej from Stanford University. Thanks a lot
Thank you.
to you and to everybody who participated.